that in front of dog that some food will be there. So what happen if we want to train our dog, if we are just ringing a bell, so what that means, if we are trained to them, when the bell will be ring, it shows key okay that the dog will be automatically the automatic dog minds will be initiated that think okay, now that it will be the food time will be going for that dog. So we are having that these are the branches of the machine learning will be there. We are having supervised, unsupervised, and now what happened that we are having that we are discussing with the reinforcement learning will be there. And in reinforcement learning we are having supervised part, machine learning part, as well as the unsupervised learning part will be there. So phases of reinforcement learning, that where we are using, and these things we have already discussed with them. And in supervised learning what happened, we are learning with that classification, regression, and in unsupervised we are going for that is clustering will be there. What is we have been done in supervised and unsupervised, that we know about that what is our target, what will be our output will be going on, what will be our target. But in reinforcement learning what happened, more general than supervised and unsupervised, we are dealing with an environment, and on that specific environment we are getting that some action, and on the basis of action our state will be changed and these things will be going on. So basically what happened will be there, what we are doing there, we are having agent will be there. I will just open this thing. So what will be the basically thing that we are using there? We are having that two things will be there. This is basically our agent will be there. Agent will be representing as we are representing. This is that your agent, and we are having an environment. This will be known as your environment will be there. Okay. Now what happened? Just like we are taking, and a coffee vending machine example will be there. If you want to take coffee from the vending machine, what happens? You will be work as an agent. So agent, what happened when you have put down that coin? So what happened after putting that coin? You will just make some selection will be going on, and on the basis of that selection, what happened? That whatever that the selection you have been made, that is your light coffee, and whatever green coffee and lemon tea, whatever you have been just made from the selection, that will be the game. So basically what happened, agent is doing some that is action will be came. What happened? First the agent will be doing some action. What will be that action this see, this action will be going on, and that action will be going to the specific environment. And when whatever the action you have been put it down in the specific environment, on the basis of that particular action your state will be changed. So what will be changing? That your state will be changing there with the help of that this environment action will be there. And whatever the state you have been changing, on the basis of that state, whatever you have been state have been changed, you are getting the reward. What you are getting? You are getting that your rewards will be getting there. So basically that this you are in reinforcement learning when we are going for that Markov property, or what are the components of reinforcement learning when we are going to there. So we are having that will be the agent will be there. First component is the agent. This is the agent will be that your first component. So this is your first component. The second component that we are working on, that is the action. Third component that we are working, that is the environment. And fourth component, that is your state. And the next fifth component, that is your reward. So these all things that we have been going on discuss with that in that our this one reinforcement learning. So we are using these five components will be there. So here what happened when we are discussing about that markup decision process model will be there. So we are having markup property will be there. What will be the markup property will be there? The markup property is that if agent in a particular state, and if it was taking any action, the next state will be depending on the current state, and current environment will be depending on the previous environment. So that will be going on. So same thing will be going on there. The environment will be there. On that environment, the agent will be taking some action, and that action will be going on in that environment. On the basis of that particular environment, the reward or the new state will be going on change. So now that will be a more clear diagram will be there. What happened in the reinforcement learning, what will be going on there? We are having that agent will be there. Agent will be working on some policies. What we have having that defining some policies will be there. We are having some reinforcement learning algorithms will be there. The agent is will going to put down some action, and the action will goes to that particular environment. On that particular environment, either the agent is getting reward, or it will be having some observations will be going on there. So we are having that some examples will be there. We are having that automated vehicle control will be there. Just like unmanned helicopter learning to fly and perform stunts will be there. Game playing, we are having that various tic-tac-toe and other game playings will be there. We are having medical treatment planning will be there. We have just in that previous that semester we have discussed with chatbots. So we are working with the help of these in reinforcement learning. These are the examples of reinforcement learning where we are deploying the reinforcement learning. So just like the robotics and locomotions will be there, according to that what motion will be going on and other things will be going on the basis of that what action you want to take and what will be that observations if this action will be going on. So basically what happens whenever you are going to conduct any this one agent, so the agent is doing first that action will be done inside the environment. On the basis of that whatever action you have been done, the current state will be changed, and on the basis of whatever the state you have been changed, that you are getting reward. So that will be going on there. So here we are having we are discussing an example will be there. So the example will be just like that. We are having a robot in a room, and this will be the start will be there, and this will be a black zone will be there here. So the robot will be having that reward will be, you will be just treated like that. Okay, this will be a trophy for that robot will be there. So now we will changing that little bit this one. This will be we are treating as this will be a trophy will be there. So we are creating that this agents wants to just achieve this trophy. Okay. In some books, they have designed that this black zone will be some flames will be there. So it will be going on. And if now what happens, we want to that go to from this point to this point, that is plus one. And always when we are going, we are getting that our reward will be there. So always what happen, our reward will be one. Now we are starting from this point. This point is for our starting point is there. this will be this current position will be our start point will be there. Now we are having different moves will be there. What are different moves will be there? Up, left, right, and down will be that we are having different moves will be there. On the basis of these moves, when the agent, if we are saying the agent want to put down some action, so what that action will be there, the action will be depending on what four actions we have been taken: up, left, right, and down, that we will be going on. Now what we are doing, we are having the different paths will be there. We can't go like when we are discussing about the first move, if we are going to in that direction, what happen, this is the black zone or the flames will be there, so you will be having that you will be destroyed. Same like that in Mario game, if you have been seeing that in Mario game, what happened if you are carrying that the Mario is having healthy, or it was having additional bonus point, and if it was interacting with the that some object and whatever these creatures will be there, then what will be going on, it will be reducing its size. But if its size is reduced and it will interact with these birds and this object, the Mario will be died. So basically we are not going in that direction. So what are the two other options will be there? We are having this option will be there, and this option will be there. So now what happened, what will be going on the policy, what we have been discussed previously, that we are having some policy is there. In that policy, what we have been defined, what will be our next move, what will be our optimal move will be going to the next one, next direction, whatever the move will be there. So now that is clear. First one, that is your initial stage will be there. On initial stage, we are deploying some policy. In that, before deploying any policy, first we will put the, we will go ahead. What are the moves? What action we want to take on? What are the actions will be there? We are having actions will be move, left, right, down. These will be the actions will be there. And on the basis of your moves, now we will be analyzing, maybe that we are having some that values will be in that particular, these boxes will be there. What will be our ultimate goal will be there? This person or this agent wants to move to that this trophy, or this will be going on there. So now that is clear. What will be the agent will be there, what will be the action will be there, what will be the policy will be there, and what are the different moves that we are going on. Then other example is that what we are doing that thing, okay, okay, that we are having a pole balancing game is there. We are having that okay, now I will give you that one example will be there in reinforcement learning. If I am telling you ki you are getting that 5 marks, if I am not telling you that out of 10, out of 20 and 30, so that will be that now you are not in position na? You will tell me that thing whether you are getting that 5 marks out of 10, 12 and 20, what will be there. So what you will be, either you are having that reward you are getting, you are having good, or this one bad, and whatever reward you are getting, so that will be there. These are the some examples that we are going on. Then we are having some resource allocation and data centers will be there, where we are having that different balancers will be there. Just like we are, if we are using that different applications, application A, application B, application C, on the basis of that these applications, our load balancer will be going on there. So a hybrid this one reinforcement learning approach and automatic resource allocation approach that we are using in the reinforcement learning. Next thing, that is the basically that book will be there. In that book, this one, the Richard Sutton and Andrew Bartow reinforcement learning and introduction will be there. In that book, that 4 chapters, the first 4 chapters will be cover your unit 1. Any doubt about these 5 elements and this agent, action, environment, reward, and state? Shall we go ahead? Any doubt is there? Now, these are Okay. These are some learning from experience, that what will be the play and role in the reinforcement learning, what are the different that application areas and domain areas where we are deploying that reinforcement learning. We are deploying in artificial intelligence, we are deploying in control theory and operations research, artificial neural networks, neuroscience, and psychology. These are the some fields where we are deploying that this one reinforcement learning. This thing, just like we are having that, an example will be there, how to program a robot to ride a bicycle. So that also comes in that in reinforcement learning, because we don't know na, what will be the moves and what will be the situation will be there. If we are having that smart cars will be there without driver, that we are getting that unmanned planes, and these will be there, so that we all these programs will become in reinforcement learning. So basically, what will be the idea of reinforcement learning is there a way of programming agent by reward and punishment without specifying how the task is to be achieved. So what will be the basic, that most important thing that we are discussing there, that is that the environment, the agent will be learned from the environment, and whatever he was learning and whatever the action he was doing, on the basis of these actions, either he is getting the reward and or punishment. Reward means the value will be increasing, and the punishment means that it was having that decremented, the value will be decremented. And what will be that the state, on the basis of action the state will be changed. Now we are having that learning to ride a bicycle will be there, we are having agent will be there, and the agent is having some environment. And but if you don't know to ride a bicycle, but you will be start with yourself, so whatever action you have been played, on the basis of actions what you have been playing, you are getting that reward or punishment will be going on. But here what happened, that the main the concept will be that we are just changing the state for the same. Next one, if we are learning to ride a bicycle, what will be there? What will be the states will be there? Angle of handlebars will be there. Angular velocity of handlebars will be there. Angle of bicycle to vertical. Angular velocity of bicycle to vertical acceleration. These are the some states that will be while you are riding a bicycle. Then learning to ride a bicycle, what that means, that according to that particular environment, whatever that these states will be there, whatever actions you have been performed, on the basis of these actions, your what will be that actions will be there, you have been applied that what kind of that balancing and whatever that paddling and other things will be going on there, that with the help of this one you ride a bicycle. So these all came in that all the actions will be there. So with the help of that environment, you will just ride a bicycle for the same. So these will be that either that if you have been that angle of bicycle is greater than 12 degree or something will be there, what will be that reward, that your bicycle is moving. And what will be that punishment from you are having, that punishment will be, or the negative reward will be, you will be fall down from the bicycle. So that will be there, that we are discussing there. Then learning to ride a bicycle, that we are using this reinforcement learning to how to learn this thing. So with the help of that the particular environment, there is no tutor will be there, there is no that instructor will be there who will taught you that how to buy that ride how to learn that ride a bicycle. With the help of that, whatever the action, whatever the environment will be there, you are learn to that ride a bicycle. When you are going to take a good step, so you are getting a reward. And if you are not getting a good step, you are not taking in that right direction, you are getting a punishment. So that will be that learning to ride a bicycle. So basically this reinforcement learning, a trial and error learning, this method will be there. On the basis of this trial and error method, we are getting that reward and punishment will be there. And we are having that many algorithms will be there. On the basis of this algorithm, we will design new paradigm, behavior control, and other things will be there. So now that is clear, that we are having that agent will be there. The agent is going for that in the environment, with the help of some action will be going on in that environment, the agent will be learned. On the basis of action, the specific state will be changing, and when the state will be changing, then evolution will be going on the basis of that particular evolution, you are getting reward or the punishment will be going on. So we are having that non-supervised learning. If you are taking that, we are having the input agent will be there, output we are going in that right direction, not right direction, whatever we are having, the output will be there, what will be our target will be there. So that's all thing will be discussed in that reinforcement learning. And that is the example of non-supervised learning will be there. And we are having examples of reinforcement learning. RoboCup Sugar teams will be there, inventory management will be there, dynamic channel assessment will be there, elevator control will be there, many robots will be there, jellyfish. So these are some examples of reinforcement learning. So now we are having some applications. Board games will be there. We are having that board games, chess games, and other things will be there. Mobile robot controlling will be there. Sequence processing control will be there. So these are the some examples that we are using for reinforcement learning. So what will be that the key features of reinforcement learning will be there. Learner is not told which action to take, and trial and error search will be going on. And we are just exploring this according to the environment, whatever the actions we have been performing. On the basis of this probability that we are going in that right direction or the wrong direction, and that all things, these are the key features of reinforcement learning. So these are some examples will be there. While drilling, game playing, online banner advertisement, restaurant selection will be there. The four main elements will be policy, reward, valuation function, and optimal mode of the environment will be going on there. So policy. So now that we are discussing in depth, what will be the policy will be there. A policy is mapping when you are just like we are having start to when we are going for that, we have discussed in the previous example, we are on the start position, and now we are having that different moves will be there. The different moves will be right, left, up and down will be there. So which move that we have been decided, that depends on that specific policy, what next action you have been going to take. So that the terminology will become what next move you have been going on, that depends on the specific policy that you have been determined in the specific policy. What will be the reward signal will be there. If you are going, whatever the action you have been taken from your previous state, you are in current state will be there. On current state you are having the different these moves will be there, up, left, right, down, these moves will be there. On the basis of these moves you have been taken some policy, and with the help of this policy what action you have been taken. So whatever action you have been taken, either that action will be going in that reward condition, or it goes in that your punishment. If the action, whatever the move you have been taken, it was going in that positive direction, or we can say that you are getting some reward will be there. So your that will be known as your reward signal. Value function means that whatever that the values we are having, that we are moving to there, that what will be values, that discount factor and other things, what will be value, that always that whenever you are going to your goal will be there, na, your starting position, and whatever your goal or target will be there. Target is actually always the target value is your equals to 1. So whatever this value function, the value function will be always, the value will be came from that 0 to 1. So now this diagram will be there in that agent environment interface, how the things will be going on. So what we are going to there, we are having a agent will be there. The agent, we are determining that agent on that particular, this one, the agent is going for an action, and it will be representing as AT. So the T will be the time of interval will be there, or sorry, that will be the A1. What will be that we are having that time intervals will be there. So on that particular time interval, what action we have been going on, and the environment will be there. So in environment, what we are having that different states will be there. The states will be that this one, S1, S2, ST, whatever on the basis of basis of that action, some state will be changing, it will be going on. So the state will be, next time the state will be st plus 1, then st plus 2, 3, 4, 5, like that, this will be going on. Same thing on the basis of when this state will be changing, and in that environment we are getting reward. If we are getting reward, so our r value will be going to change. Okay, so that will be there. Agent and environment interact at discrete timestamps. That we are representing these timestamp will t, and the t will be 0, 1, 2, up to whatever that we are having. And agent observe that state will be at step t, and what will be that all that these steps that belongs to that capital S. And whenever we are producing an action will be there, so we are going to do like that, and we are getting that result and the reward that will be going on. So same thing that we have been representing through with that this slide, that how we are moving from that this will be the first state, then we have taken that an action. On that action we are, our state will be changing, so that's why we are getting that some reward will be there. Again that our state will be changing, then we are having action, reward. It we are assuming that there we are getting that only that rewards will be there, but it may be and probability will be there where we are getting that punishment also, or the reward value will be going in that negative direction also. Then agent learning policy will be that agent learning policy we have been defined with the pi, and the pi value will be the t will be the time interval, that whatever that on the specific time interval that we are taking some actions will be there. So always that the policy will be mapped from S means that current state, and the state and what action you have been going on that particular state. So what will be the probability of that will be that on that specific time, whatever the action on that specific the time interval you have been taken, on the basis of that particular action, your state value will be changed. This is the agent learning policy will be there. Agent interface, again that whatever that we have been discussed, the same thing will be came. The agent learns policy will be there. Goals and reward we have already discussed. Now that returns and the expected return on the specific that states we are just going to discuss. Return counting task will be there. This will be the example that we have been discussed already. So these are some basics for reinforcement learning that we go through. So that is the depth. Now we are going to discuss that what will be going on there. So that's the reinforcement learning, that history of reinforcement learning, where that this reinforcement learning concept will became, that we have already discussed that thing, history of reinforcement from the animal learning, that they have taken that example of the cat will be there. Cat will be that put it down in some box, and we are having that some that door outside that we have put down some that cat food will be there, and inside that some levers will be there. So that cat will be that on the basis of that whatever the action that the cat have been performed, on the basis of that action the state of cat will be changing. So once that this door will be opened, then the cat will be eat their food. So these are the animal learnings example will be there. We have already discussed that this dog training example will be there. So these are two examples that will became in that the category of animal learning. Then the Turing example, you have already discussed about Turing machine and the Turing, these examples will be there. Electromechanical examples will be there. Trial and error will be that one, these examples will be there. that we this will be electromechanical, this example that will be dealing with neural analog reinforcement will be there. So we are not discussing too much these examples, but automata will be there, neurons will be there, temporal difference will be there. Q learning, we have already discussed that thing. What we are doing in that Q learning will be there. So that is the history from where that it will be derived, this all these things. That is an example of that self-driving car we have been discussed, advanced detection and the stop bar. And this will be that basically that this will be what they are doing, that road traffic, what action they have been doing, that traffic signal and all these things you are be just go ahead with. And that is only the overview that I am giving, that so many examples that you can go through. Tic-tac-toe game will be there. In tic-tac-toe game, you know very well that 0 1, and if that straight line will be came, then you are moving. So initially that what will be the initial state will be there. Initial state that we are just using that 3 by 3 matrix will be there. And what will be the operators will be there. Operators will be 0 or x will be there. What will be the terminal test will be there, which determines game is over and complete when we are horizontal, vertical, and whatever the row will be framed by x or the 0, that is your win-win situation will be there. So games and the searching parameters will be there. Games playing strategy will be there. Min-max algorithm, and you have already alpha, beta, purine, and these algorithms you have discussed in that AI subject previously handled subject. So now tic-tac-toe, this they are giving that example. We start moves with playing in. Then what will be that the next step that we will be going on there? So loss will be going on. Maybe that again the loss will be going on. Again that tie will be going on. Tie means nobody will be win. So again that we are going for, if we are using that different these scenarios and whatever according to your action and moves will be going on. So one point will become where that according to your turn, whatever the action you have been performed, on the basis of that particular action, what happen, either you are in win-win situation or you are going in that tie situation, that will be going on. So that we have been done there. Then there will be the, and black uses the strategy will be there. What will be the rule that we have been defined for that thing? That will become that what rule if that corner will be there, if that will be if something will be going on there. So what rule you have been defined? If maximum win situation you want to that increase for your thing, so you will put down the dark circle in that mid. After that you will be having that another other things. These are all these things will become in that your policy. That is a game tree example of tic-tac-toe. We are starting with max, then min, what max and whatever terminal and whatever utilities will be going on. So that is your min-max algorithm. You have already that studied this min-max algorithm. That is continued. DFS and weight, whatever the payoff will be there. We are having some limitations. Alpha beta pairing, you know very well how that alpha beta pairing example will be there. We are just considering that the value with the delta, and delta we are again that we are covering with them min max, and that if the value will be not, and we are having that this children matter, and whatever the rule we have been applied, this all these things, the property of alpha beta pairing, and these all these things will be going on there. So there is an extended example of tic-tac-toe, what we are going. Starting position, RL learning tic-tac-toe, what will be that starting position, that our moves and other things will be going on. So whatever this TD game will be there. So these are some examples where that we are using that our what we are saying, that is our reinforcement learning. So these are that is some overview about your that reinforcement learning. Today what we have been discussed, maybe that you are aware about that these what we are saying, reinforcement learning, that what will be their components will be there, and what are the examples will be there, what will be the history of the reinforcement learning will be there, and what are the components that we are using in it. And in tomorrow's lecture, whatever the lecture we have been scheduled online, that maybe that tomorrow if I am carrying time, I will schedule a lecture for 1 hour. In that we will be discuss about that Markov decision process, that this model. And we are having that another the important concept will be the Bellman equation will be there, that we will discuss in that tomorrow's lecture. Whenever I am having time, I will schedule that thing. So that is that overall this thing for that we are using this reinforcement learning there.